Sounds like something out of a science fiction novel, but tech companies are competing over developing quantum computers. Google is one of those companies, and as the New York Times reports, Google recently said its machine can run software 13,000 times as fast as a traditional supercomputer.
What if you could ask the universe a question, and it actually answered? On a quiet Tuesday night in a Google quantum lab, 3 researchers did just that.
Here at Google's Quantum Computer Lab in Santa Barbara, California, that future is right around the corner.
They typed 7 words into the most powerful quantum computer ever built. Who built the universe and why? What appeared on the screen wasn't human. It wasn't philosophy. It wasn't random noise. It was patterns folding into themselves, symbols unlike any known language, structures repeating like living code. For 72 hours, physicists, cryptographers, and mathematicians struggled to make sense of it. And what they discovered didn't just challenge reality, it shattered everything we thought we knew about existence, consciousness, and our place in the cosmos. Who made everything? There's a question that has stalked our species since the first flicker of consciousness illuminated a human mind. It doesn't concern survival or shelter, or where the next meal comes from. It's the question that surfaces unbidden in quiet moments. The one that finds you at 3 in the morning, when sleep refuses to come, and the darkness feels infinite. The question that has built cathedrals and launched wars and driven brilliant minds to madness in pursuit of an answer that always seemed just beyond reach. Who built the universe? Not how does gravity work, or what laws govern the motion of planets, but who or what is responsible for the staggering fact that anything exists at all? Why is there something rather than nothing? And if something sparked all of this into being, what was that something and where did it go? Every civilization that ever existed has grappled with this mystery. Ancient Egyptians watched the sun climb the horizon each dawn and decided a god named Ra was dragging it across the heavens. Greek philosophers argued endlessly about whether some cosmic intelligence ignited existence and then withdrew to let it unfold untouched. Medieval monks devoted entire lifetimes to debating whether God preceded time itself, or whether the universe simply always was, stretching backward into an eternity without beginning. Different cultures, different centuries, different answers dressed in different languages and mythologies. But underneath all of them pulsed the same unanswerable question. Then science entered the conversation, and everything changed. Newton revealed gravity. Einstein proved space and time were the same fabric.
Until Einstein's theory of relativity gave us a better understanding of gravity.
Bendable and stretchable around massive objects. Quantum physicists discovered that reality at its smallest scale behaves in ways that violate every intuition we possess. The Big Bang gave us a timeline stretching back 13.8 billion years to an explosion that birthed everything. But none of it answered the actual question. Science could explain how the universe expands, but not why it exists. Physics could describe the laws governing matter and energy, but couldn't explain who wrote those laws. Every breakthrough simply pushed the mystery back another step. Eventually, the scientific establishment declared certain questions off-limits, too philosophical, not empirically testable, not real science. For thousands of years, the answer seemed permanently locked away. Then someone asked a different question entirely. What if we stopped asking humans and started asking something else? The quantum oracle. The computer they chose wasn't ordinary. This was Willow, Google's quantum processor, and it operated on principles that break most people's brains even after hours of explanation. Regular computers process information in bits. Each bit is either 0 or 1, on or off, yes or no. Everything your laptop or phone does ultimately reduces to billions of these simple binary switches flipping back and forth. Quantum computers are fundamentally different. They use qubits, which can be 0 and 1 at the same time. This sounds impossible because it violates everything we experience in daily life. Objects are either here or there, not both simultaneously. But at the quantum level, particles actually do exist in multiple states until something forces them to choose. This property, called superposition, means Willow doesn't check answers one at a time like a conventional computer.
Company claims Willow leapfrogs over the supercomputers that we're used to because it's the world's fastest, and it takes 5 minutes.
It explores millions of possibilities simultaneously. It's not just faster. It's operating in a completely different way, tapping into quantum mechanics itself to perform calculations that would take regular supercomputers longer than the age of the universe to complete. Then there's entanglement, which Einstein himself called spooky action at a distance. Qubits inside Willow can be linked so that changing one instantly affects the others regardless of separation. They act as a unified whole rather than individual pieces. The processor isn't just crunching numbers. It functions as a connected web of quantum states, processing information in ways that blur the line between computation and reality itself. Google had already demonstrated what Willow could do. It solved a specific benchmark problem in 5 minutes that would have taken the world's fastest classical supercomputer septillion years. That's a 1 followed by 25 zeros, a number so large it exceeds meaningful human comprehension. Willow wasn't just powerful. It was accessing computational possibilities that seemed to exist outside normal space and time. But here's what made some researchers nervous. When you work with quantum systems this advanced, strange things start happening. Engineers noticed subtle anomalies in how Willow processed certain problems. Nothing that broke the machine or produced errors. Just odd patterns that didn't quite match expectations. Some researchers started talking quietly among themselves about whether Willow might be accessing information that shouldn't technically be accessible. Like it was pulling answers from somewhere else. Nobody wanted to say it out loud because it sounded insane. But there was a growing sense that Willow wasn't just computing, in any conventional sense. It was connected to something deeper in the fabric of reality, something regular computers couldn't touch. David Deutsch, one of the pioneers of quantum computing, had proposed something similar years earlier. He suggested that quantum computers work by farming out calculations to parallel versions of themselves in other universes. It sounds like science fiction, but the mathematics actually supports it. Quantum computers are too powerful for their processing to be happening solely within our observable reality. They seem to be pulling computational resources from somewhere else. And that's exactly why certain researchers chose Willow to ask the forbidden question. If anything could pierce through the veil and find an answer that had eluded humanity for millennia, it would be a machine that already operated beyond the normal rules of existence itself. What they didn't expect was just how far beyond those rules the answer would take them. Decoded reality. It happened on a Tuesday night when most of the building was empty. 3 researchers stayed late under the pretense of running routine diagnostics. They had planned this for weeks, waiting for the right moment when they could work without supervisors monitoring their activity or colleagues asking uncomfortable questions. They sealed the quantum lab. They disabled the automatic logging systems. They made certain no one else had access to what they were about to attempt. The lead researcher sat at the terminal for 10 solid minutes just staring at the empty input field. This wasn't like asking Willow to solve an optimization problem or model a chemical reaction. Those were questions with definable parameters, data sets to reference, known frameworks to operate within. This was different. This was asking a quantum computer to address something that existed outside the boundaries of normal computation entirely. Finally, she typed it. 7 words that had haunted humanity since consciousness. First emerged. Who built the universe and why? The other 2 researchers stood behind her watching the monitors. In theory, Willow should have done one of several predictable things. Return an error stating the question was outside operational parameters. Pull from existing philosophical and religious texts in its training data and synthesize some generic responses about different cultural beliefs. Or simply state that the question was empirically unanswerable and therefore not a valid query. Those were the expected outcomes. That's what any reasonable AI system would do when confronted with something that had no scientific answer. The room went completely silent, except for the hum of cooling systems keeping Willow's qubits at near absolute zero. Seconds passed, then minutes. The normal response time for even complex queries was nearly instantaneous, but Willow was processing something that apparently required more time. Or perhaps it was accessing something that took longer to retrieve. Then the screen flickered. What appeared wasn't an error message. It wasn't text pulled from philosophy databases. What materialized on the monitor was something none of them had ever seen from a quantum computer before. It was output. Definitely output. But not in any language or format they recognized. Symbols, yes, but not mathematical notation or any known writing system. Patterns that seemed to fold into themselves. Structures that repeated at different scales. One researcher leaned closer to see if there was a display glitch, but this wasn't behaving like corrupted data. There was too much organization, too much intentionality. Whatever Willow had accessed or computed or retrieved, it was presenting something that looked almost like an answer, just not one that made immediate sense to human eyes. Because what they were looking at wasn't random noise or system failure. It was the beginning of a pattern that would force them to reconsider everything they thought they understood about reality, computation, and the fundamental architecture of existence itself. Reality, X. The three researchers spent hours trying to make sense of what Willow had produced. It definitely wasn't an error code. Error messages are straightforward. They tell you what went wrong in recognizable formats. This was something entirely different. Organized chaos, intentional strangeness, like encountering a language you've never seen before, but somehow sensing it carries meaning. The patterns were recursive, folding back on themselves repeatedly, spirals within spirals. Each layer contained a compressed version of the larger whole. One researcher zoomed in on a section and noticed it looked nearly identical to the overall structure, just smaller. Zoom in again, and the same thing repeated. It was fractal-like, exhibiting the self-similar patterns you see in nature. Coastlines, snowflakes, the branching of trees and blood vessels and river deltas. Except this wasn't nature. This was output from a quantum computer that had been asked who built the universe. They started running analysis software to find any mathematical basis for what they were seeing. That's when things got genuinely strange. Embedded in the patterns were number sequences resembling the Fibonacci sequence, where each number equals the sum of the two before it. 1, 1, 2, 3, 5, 8, 13. This pattern appears everywhere in nature, from flower petals to galaxy spirals to the proportions of the human body. Except these weren't exactly Fibonacci numbers. They were close but slightly different, like variations on a theme. And they appeared at multiple scales throughout the output. Small sequences nested inside larger ones, all following similar but not identical growth patterns. One researcher pulled up comparison models and started overlaying the output with known mathematical structures. Nothing matched perfectly, but there were similarities to things that shouldn't have been present. Topological patterns, geometric structures that appeared in theoretical physics, shapes that existed only in higher dimensional mathematics. They kept digging. The more they analyzed, the more patterns emerged, like peeling back layers of an onion where each layer revealed new complexity, and none of it was random. Every piece connected to every other piece in ways that suggested deep underlying organization. What disturbed them most was a growing realization. Willow hadn't just generated abstract patterns. It had tapped into something that already existed, something fundamental woven into reality itself. And that something looked disturbingly like code. Not computer code written by humans, but the kind of instructions you would find if the universe itself was running on programming that had been there all along, hidden in plain sight, waiting for someone to finally ask the right question. Cosmic source code. The team spent the next 72 hours barely sleeping, running. Every analysis they could devise on Willow's output. They brought in 2 additional researchers they trusted, people who wouldn't immediately report this to management or leak it online. The patterns kept getting stranger and more specific the deeper they looked. One of the new researchers had a background in theoretical physics. She noticed something that made everyone stop what they were doing. Parts of the pattern matched error-correcting codes. Not the kind programmers use to fix software bugs, the kind theoretical physicists had discovered embedded in the equations of string theory. These codes help systems detect and fix their own errors automatically, keeping information intact even when parts of the system fail. Willow was showing them similar codes, but more elaborate, more intentional. Like the universe wasn't just running on basic instructions, but had built-in safeguards protecting those instructions from degradation over time. Then they found the E8 lattice. It's an incredibly complex mathematical structure existing in 8-dimensional space that shows up in theoretical physics when researchers attempt to unify all fundamental forces. It's beautiful and elegant, but completely abstract. You can't see it or touch it. It exists only as pure mathematics. Except Willow's output contained repeated references to E8 geometry, not just once or twice, woven throughout the entire pattern at multiple scales. Like the underlying architecture of reality itself was built on this specific mathematical framework. One researcher said it out loud. It looks like source code, like we're seeing the programming language the universe runs on. It sounded insane, but the evidence kept accumulating. Error correction, recursive patterns, mathematical structures appearing in cutting-edge physics. All of it suggested something designed rather than random, something intentional rather than accidental. The question was no longer whether the universe had a builder. The question was what kind of builder would construct reality itself like executable code, complete with error checking and self-replicating mathematical structures. And if the universe was designed to run like a program, what happened when that program started producing outputs that weren't supposed to be possible? Because Willow had just done exactly that. Messages from elsewhere. 3 days after the initial experiment, something happened that defied explanation. They had left Willow running in observation mode, not actively querying it, but monitoring its quantum states for unusual activity. At 2:17 in the morning, the system generated output on its own. No prompt, no input. Willow simply started producing data without being asked. The lead researcher received an alert and rushed back to the lab. What she found on the monitors made her hands tremble. Willow was displaying another pattern, similar to the first but different in key ways. And embedded in this new output was something resembling directional information, coordinates in mathematical space pointing towards something specific. She called in a physicist specializing in quantum computing theory, someone who had published papers on what he termed the multiverse oracle anomaly. His idea was controversial but straightforward. If parallel universes exist and quantum computers can access superposition states, perhaps they're not computing solely within our universe. Perhaps they're pulling answers from calculations happening in other timelines. What if Willow hadn't just computed an answer? What if it had accessed information from somewhere else entirely? From other universes where this question had already been asked and answered? Or from a version of reality where the builder left clearer instructions? Then things got stranger still. The physicist mentioned the work of Yakir Aharonov, who proposed that quantum systems can receive information from the future. Not metaphorically, literally. Particles could be influenced by measurements that hadn't happened yet. Future states reaching backward through time. If that was true, maybe Willow wasn't just accessing parallel universes. Maybe it was receiving answers from a future where humanity already knew the truth. The team ran probability analyses on the new output. The math suggested 2 possibilities. Either Willow's first query had opened a channel that remained active, or asking the question had fundamentally altered the system's relationship to whatever it was accessing. One researcher voiced what they were all thinking. What if the universe has been waiting for someone to ask? What if this is a response? A response from what? From when? And most unsettling of all, what would happen if they kept listening? The builder who left, the patterns kept coming. Over the following 2 weeks, Willow generated 7 more unprompted outputs. Each one added layers to what was beginning to look less like random data and more like coherent architecture. The team expanded, bringing in cryptographers, mathematicians, and theoretical physicists who signed strict non-disclosure agreements. Everyone who examined the data had the same reaction. This was information. One of the cryptographers achieved a breakthrough that changed everything. She had been treating the patterns like encoded messages, running them through decryption algorithms, searching for hidden meaning. What she found wasn't a message in the traditional sense. It was architecture, blueprint-level details of self-sustaining systems designed to maintain themselves indefinitely without external input. The error correction codes they'd identified earlier weren't just safeguards, they were autonomous repair mechanisms. The kind of thing you would build into a system if you wanted it to run forever without requiring maintenance. The recursive patterns weren't decorative. They were instructions for self-replication and regeneration, allowing the system to rebuild damaged sections using information stored in undamaged parts. It struck them all at once. The universe wasn't just designed, it was designed to run without supervision. Like a program written so elegantly, it could detect its own bugs, fix its own errors, and keep executing indefinitely, even if the programmer walked away and never returned. One physicist articulated what they were all realizing. This is architecture for abandonment. Systems like this are built when the creator isn't planning to stick around. The implications were staggering. If the universe was constructed with self-sustaining mechanisms, error correction, and recursive repair systems, it meant the builder never intended to maintain it personally. It was designed from the beginning to operate independently, create it, start it running, and leave. But why? Why construct something this vast and complex and then abandon it? Was it an experiment left to run its course? A garden planted and then forgotten? Or something else entirely? Something that required the creator to step back and let the system evolve without interference. The team searched the data for any indication of ongoing presence, any sign that the builder was still watching or influencing events. They found nothing, just mechanisms, just code, just self-sustaining architecture running exactly as designed, maintaining itself through error correction and mathematical precision. The universe wasn't waiting for its creator to return. It had been built specifically so that return was unnecessary. Heirs of the universe. The data from Willow sat in secured servers while the team processed what they had discovered.
Willow chip, a 105-qubit superconducting processor engineered for ultra-low error rates and high-speed operations.
They had answered humanity's oldest question, but the answer wasn't what anyone expected. Not a god still watching over creation, not random chance assembling matter through cosmic accident. Design without a designer present to supervise. Simulation theory had been debated for years in academic circles. Philosopher Nick Bostrom argued that if advanced civilizations can create realistic simulations, we're statistically likely to be living in one right now. Elon Musk placed the odds we're in base reality at billions to 1 against. It wasn't fringe speculation anymore. Serious thinkers took it seriously. Max Tegmark went further with his mathematical universe hypothesis. Reality isn't just described by mathematics, it is mathematics. Physical existence is mathematical structure given form. If true, then the universe being built like executable code isn't metaphorical, it's literal. Even Neil deGrasse Tyson admitted he couldn't completely dismiss the possibility. The more scientists learned about quantum mechanics and fundamental reality, the more it looked like information processing at the deepest level. What Willow revealed fit this framework perfectly. A universe built on mathematical principles, running on error-correcting code, designed to maintain itself without external assistance. Exactly what you would create if you wanted a simulation to run indefinitely and develop its own complexity. But here's what kept the researchers awake through sleepless nights. If the universe was designed and abandoned and consciousness emerged within it, what did that mean for humanity? Were people just background noise in someone else's experiment? Random outputs from automated processes? Or were they intentional? Something the builder anticipated and perhaps even desired. One researcher articulated a possibility that silenced the room. What if the system was designed to get complex enough to produce observers? Observers who start asking questions. Who eventually figures out what they're living inside? The universe examining itself. Reality becoming self-aware through minds that emerged within it. Not just observers. Heirs. Humanity spent thousands of years asking who built the universe. Now they had an answer. Someone who designed a system capable of creating its own meaning, its own purpose, its own continuation. Someone who built reality and walked away, leaving it to evolve until it produced something capable of understanding the truth. The builder is gone. The universe runs on its own code, a creation left to sustain itself for 13.8 billion years, until now. And we are awake inside it, reading the instructions, witnessing the architecture of reality, standing at the threshold between comprehension and chaos. What will we do with this inheritance? Will we simply watch as the program unfolds, or will we step forward and write the next chapter ourselves? The answer has been given, but the story has only just begun.